Hey, so welcome back to our notes for example 3 in piecewise functions. In this example, we're going to be looking at characteristics of piecewise functions, such as finding the y-intercept and finding the zeros algebraically. So we're not going to sketch the graph of this piecewise function just yet. Instead, we're going to examine the equation and see if we can find algebraically the y-intercept and the zeros. So up at the top here are some reminders about y-intercepts. The y-intercept occurs on the graph where the x equals 0. So if you're looking at your subfunction, remember that's in front of the comma, right? The subfunction x plus 3, that occurs only over the subdomain where x is strictly less than -1. If I were to put a 0 in here, is 0 less than -1? And the answer to that question is no. So I wouldn't use this linear subfunction to find the y-intercept. Okay, when I look at the quadratic subfunction, -x² plus 3, that is defined where x is greater than or equal to -1. Is 0 greater than or equal to -1? And since that's true, I'm going to use that quadratic subfunction to find the y-intercept. So I'm going to take this -x², but instead of x, I'm going to put in a 0. So I have -0² and then plus 3. And 0² is 0 times a negative is still 0, plus 3 is 3. So my y-intercept is at 3. And you can write that as just a 3. You can write it as the ordered pair, 0, 3. However you want to represent that is fine by me. So y-intercept at 3. Okay, now we want to locate the zeros of this graph. And for the zeros, those occur where we have the point x, 0. So we need the y to be 0 to find the x-intercepts. Now I can't tell anything about the y's when I'm looking at the subfunctions or their subdomains. So to find the zeros, we have to set each subfunction equal to 0 and solve for x. And then once we know what x is, then we can check those zeros against our subdomains to see if they're part of the solution set or not. So first I'm going to start with my linear subfunction, which is x plus 3. And I'm going to set that equal to 0. Then when I subtract 3 from both sides, I'll have x equal to -3. So let's fix that equal sign there. So x equal to -3. Now I want to check that against the subdomain up here for that linear subfunction. So when I check, I'm putting in this -3 in here for x. So is -3 less than -1, right? That's what I'm asking myself. And -3 is less than -1. That's true. So since that's a yes, this x equals -3, that is a 0. Okay, so that one checks. Next, we're going to look at the quadratic subfunction. So -x² plus 3, and we set that equal to 0. Okay, and when I add x² to both sides, I'll have 3 is equal to x². And to undo a square, we need the inverse, which would be a square root. So we square root both sides. And when you square root a squared variable, you get a plus or minus answer. So I have two solutions that I need to check. Either x is equal to the positive square root of 3. Wow, that made a mess. Let's try that again. So x is equal to positive square root of 3, okay, or x is equal to negative square root of 3. Right, those are the two possibilities that we want to check. And we're checking them against this subdomain of x greater than or equal to negative 1. So when I look at this first solution, I'm asking myself, is the square root of 3 greater than or equal to negative 1? And it doesn't even matter what the square root of 3 is because it's positive, and something positive has to be greater than or equal to something negative. So that tells me that this x equals positive square root of 3 is one of the zeros. Okay, it works in that subdomain. Now when I try the next one, is negative square root of 3 greater than or equal to negative 1. So now we do need to have at least an estimate of what negative square root of 3 is in order to compare it to negative 1. But we don't have to rush to grab a calculator. If we think about the number line, if we have a 0 here, and then we've got the square root of 1. So negative square root of 1 is equal to negative 1. Then we'd have a negative square root of 2, which I don't know what that is. And we'd have a negative square root of 3, which we don't know what that is. But we do know that the negative square root of 4 is negative 2. So if negative square root of 3 is somewhere between negative square root of 1 and negative square root of 4, that means its answer has to be somewhere between negative 2 and negative 1. So do you see how negative square root of 3, which is right here on the number line, it has to be a smaller number, right, closer to negative infinity than negative 1. And so since this is a no, right, that does not work in the subdomain, I cannot keep this as an answer. So I cross it off my list because it's not part of the graph that will be sketched by that function. Okay, so we have a y-intercept of 3 and 2 real zeros, one at negative 3 and another at positive square root of 3. Okay, so now you're going to pause the video and try example B on your own. Okay, you're going to first find the y-intercept algebraically and then find the zeros and check each zero that you find against the subdomains to see which ones will keep and which have to get crossed off. Okay, once you've given this problem a try, come back and we'll go over the solutions together. Okay, so welcome back to example 3B. And hopefully you took a second to try this on your own, so we'll go over it together. If we want to find the y-intercept, we want to find the subfunction where x equals 0 works in the subdomain. So is 0 less than or equal to 1? And that is true. So we're going to put the 0 for x into this absolute value subfunction. So we have negative absolute value of 0 plus 1, and then plus 4, and that plus 4. There we go. That looks better. The other one looked like a 9. And that is going to simplify to a 1 times negative 1 is negative 1 plus 4 equals 3. So we have a y-intercept of 3. Okay, now to find the zeros, we're going to take that subfunction negative absolute value of x plus 1 plus 4, and we're going to set that equal to 0. So let's make that look like an equals. And then when I add my absolute value over to the other side, I'll have 4 equal to the absolute value of the quantity x plus 1. And this is where we'll split into 2 possibilities. So either this x plus 1 that's inside the absolute value is positive 4, and the absolute value keeps it positive, or it could be the case that this x plus 1 that's inside that absolute value, that is actually a negative quantity. It's a negative 4 in there, and then the absolute value of the negative 4 is why we get a positive 4. So we have to look at both of these possibilities. So here, if I subtract 1 from both sides, x equals 3 would be the 0. And on this side, if I subtract 1 from both sides, x equals negative 5 would be a 0. Now I have to check them against their subdomain to see if they work. So with this first one here is 3 less than or equal to 1. And the answer to that is no. So we would cross off x equals 3, and that cannot be one of the zeros because it's outside of the subdomain. And then we test the x equals negative 5. So is negative 5 less than or equal to 1? And that answer is a resounding yes. And so we keep x equals negative 5 as one of our zeros. Okay, then we're going to look at the second subfunction, which is a constant right there at y equals 3. So we set that constant function equal to 0. So 3 equals 0. Does 3 equal 0? No. And there's no x to solve for, so this has no solution. And we would move on from there to our last subfunction, which is linear, 2x minus 4. So we're going to set that 2x minus 4 equal to 0, and then we'll solve for x. Let's see if we can get that to look right. So 2x minus 4 equals 0. That looks better. So when I add 4 to both sides, I have 2x equals 4, and then I divide both sides by 2, and x then is equal to 2. So I want to check that against the subdomain for the linear subfunction. So x greater than 2 would be checking to see if 2 is greater than 2. And that is a no, right? 2 is not greater than 2. So I have to throw out that as a possibility, and that means I only have one real 0 in this piecewise function, and that's where x equals negative 5.